Hello everyone. In the last class, I taught you about escape energy and escape velocity. In today's class, we shall learn something about satellites. So what are satellites? Satellites, these are the bodies revolving around the planet in a definite orbit. Okay, I'll repeat again. These are the bodies revolving around the planet in a definite orbit. So anything that revolves around a planet is called a satellite. So you might ask me that, so any object, so any rock that orbits around a planet, could it be called as a satellite? So it's not in that way. Okay, everything cannot be called as a satellite. But there are certain things, there are certain criteria that an object should follow to become a satellite. So there are asteroids, meteorites, dead rocks, there are many things. There are space junk also which revolve around a planet. So all these things cannot be called as satellites. But there are certain things which revolve around a planet that could be called as satellites. So let us learn more about this satellite. So the first one is natural satellite. So these are the celestial bodies around the planet. So there are natural satellites, like our Earth has a natural satellite. So our natural satellite is Moon. So Moon is our natural satellite. So Moon is the natural satellite of Earth. So Moon is a celestial body that revolves around our planet Earth. So like that, even our Jupiter also has its own moon. Okay. So even our Jupiter has a natural satellite like Moon itself. Okay. So Moon is a celestial body, okay, that revolves around our Earth. So Moon is the natural satellite. Okay. So the next one is artificial satellite. So what do you mean by artificial? It is man-made. So the name itself suggests that. So these are man-made satellites. So artificial satellites are nothing but they are man-made satellites. So artificially created by man. So artificially created by man, and they are made to orbit at certain height. So these satellites are called as artificial satellites. So the next one is Earth satellite. So Earth satellite, here the name itself suggests. So it says that Earth satellite. So these are the objects which revolve around the Earth, in definite orbit. So I'll repeat again. These are the objects which revolve around the Earth itself. So here, because the name itself is suggesting Earth satellite, that means the satellite should revolve around the Earth itself. These are the objects which revolve around the Earth in definite orbit is called as Earth satellite. So we have example for this, INSAT. So this is our Indian satellite. So it is named as Indian National Satellite. I hope you know this. INSAT 1, INSAT 2, INSAT 3. We have satellites, many satellites like this in this name. So I have one more example for this, Apple, APPLE. So it is an acronym for Airline Passenger Payload Experiment. Okay, so this is, and one more, Earth satellite that revolves around our Earth. So there are satellites which are made to study certain planets. Like we have a satellite that revolves around our Mars. So that satellite is called as Mars satellite. So to study our Sun, we have a satellite. For that satellite is named as a Sun satellite. So like this we can name satellites. Okay. So we have different types of satellites like this. So there are many applications of this satellites that will be explained in the further classes. The next topic is orbital speed of Earth satellite. So a satellite will revolve around the Earth in a particular orbit itself. So it will orbit the Earth in a it will revolve around the Earth in a particular orbit at a particular speed itself. So that particular speed itself is orbital speed of a satellite. It is the speed of revolution of a satellite around the Earth in a given orbit. So here the satellite will revolve around the Earth in a particular orbit. So at a particular speed itself. So with that velocity itself it will travel. So that is called as orbital speed of Earth satellite. I'll repeat again. It is the speed of revolution of a satellite around the Earth in a given orbit. Let us derive the expression for orbital speed of Earth satellite. So this is our next topic. So I told you about the orbital speed. So now we shall derive an expression for this orbital speed of Earth satellite. Let us consider our Earth, which has a mass m, which has a radius r. So let us also consider a satellite of mass m, small letter m, which is at the height h, revolving around the Earth at a speed of orbital speed v0. Okay, I'll repeat again. Let us consider our Earth, which has a mass m, center O, radius r, and let us also consider a satellite mass m, which is placed at the height h, and the satellite is revolving the Earth with the orbital speed v0. So this is the story of this one. So let us consider in this case, let us take centripetal force is equal to gravitational force. So I have taken centripetal force is equal to gravitational force. So because I have taken the centripetal force. Why? Because I told you in my first class itself. So the satellite will revolve around the Earth because of centripetal force. Okay, so it will have the gravitational force, but will revolve around the Earth because of centripetal force itself. So the same applies to Moon also. I told you in the first class, in my introduction class itself. So for that reason itself, I have taken centripetal force. So centripetal force is equal to gravitational force. So the expression for centripetal force is mv square by r. So here we have orbital speed, that is v0 divided by r mv square by r. So here mv0 square divided by, we have the satellite placed here. So we should consider r with the height h. So mv square by r plus h it will be. So it will be like this. This is equal to gravitational force. It's quite obvious that we know this. So G m divided by r plus h whole square. Okay, I hope you know this. So G m is the mass of the Earth, small letter m is the mass of the satellite, r is the radius of Earth, and h is the distance between the Earth and the satellite. Okay. So this is what we know. We can cancel this m. So r plus h one times and r plus h here it will get cancelled. So v0 square is equal to g m divided by r plus h. So this is what we got. So after this, so v0, if v0 decreases, as h increases. So v0 decreases as h increases. So v0 decreases as h increases because v0 is at the numerator and h is at the denominator. So if one increases, the other has to decrease. So it's vice versa. So it's inversely proportional here. So if v0 increases, then h has to decrease, or if h increases, the v0 obviously has to decrease here. So for V naught, let us take for the orbital speed V naught, let us take h is equal to 0. So I'll take h is equal to 0 because we are considering our satellite is revolving around the earth very close to the surface of the earth. So the satellite is revolving very close to the surface of the earth. So I'll consider like that. So for that reason I'll take h is equal to 0. So after this, what will happen to our equation? V naught square is equal to Gm divided by R. So this is what I get, Gm by R. So we also know that G is equal to Gm by R square. So we know this. So G is equal to Gm by R square. So Gm is equal to Gr square. So I'll replace this Gm and place this Gr square upon that. So V naught square is equal to Gr square divided by R. R will get cancelled. So V naught square is equal to Gr. So V naught is equal to square root of Gr. So this is the expression for V naught. So which is the orbital speed of Earth satellite. So the orbital speed of Earth satellite is completely dependent on the mass of the satellite. So if the mass of the satellite is more, then the orbital speed is also more. So if the mass of the satellite is less, then the orbital speed is also less. Okay, so you have to know this. So I'll explain you this again. So let us consider our Earth, which has a mass m and a center O, which has a radius r. Let us also consider a satellite small m, so satellite of mass small m, which is placed at the height h that revolves around the Earth with the orbital speed v naught. So let us consider in this case centripetal force is equal to gravitational force. Centripetal force is mv square by r. So we have orbital speed v naught divided by r. So we have, since the satellite is here, we have to consider r, the radius with height. So r plus h. So g is equal to gmm by r plus h whole square. So mm will cancel out, r plus h and 1 r plus h will also get cancelled. So the remaining terms I have taken as it is. So if v naught decreases, then h increases. So this is inversely proportional to each other. If one increases, the other has to decrease because one is at the numerator and another one is at the denominator. I'll take h as 0, h is equal to 0 because I'll consider the satellite to be revolving very close to the surface of the earth. For that reason itself I have taken h is equal to 0. So after taking this, I'll get v naught square is equal to gm by r. So we also know that g is equal to gm by r square. Gm, I'll cross multiply, gm is equal to gr square I'll get. So I'll replace this gm with gr square. So v naught square is equal to gr square by r. So r will get cancelled. I'll get v naught square is equal to gr. So I'll put the square root here. So v naught is equal to square root of gr. So this is what I got. So this is the expression for orbital speed of Earth satellite. So the next topic is uses of satellite. The first one is communication. The satellites are used in communication purpose. So we all use cell phones to communicate with each other. So we use internet. Okay, so all these they are because of satellites. So the next one is spying. So spying means ಕನ್ನಡದಲ್ಲಿ ಗೂಢಚಾರಿ ಕೆಲಸ ಮಾಡೋದು ಅಂತ. So spying, so people use this in defense purpose. So people while in the situation of war, they need to spy on others. So because they should be very cautious. So for that reason, they make use of this satellites. So they are used in spying. So the third one is forecasting climate. So we can know the weather report. So of each and every day, even before that day. So in the previous day itself, we can know what can happen tomorrow. So today itself we can know what will be the climate for tomorrow. So we can know the weather exactly. So for forecasting the climate, we use this satellites. So there are many uses of this satellites. These are only a few uses of this satellites. The next topic is geostationary satellite. So the geostationary satellite is one which revolves around the Earth with the same angular speed and in the same direction as Earth rotates about its own axis. So I'll repeat again, the geostationary satellite is the one which revolves around the Earth. The satellite will revolve around the Earth. So with the same angular speed. So the satellite will revolve around the Earth with the same angular speed as the Earth rotates. So the Earth will rotate around certain speed. So at that particular speed itself, the satellite will revolve around the Earth. So with the same angular speed and in the same direction. So the satellite will also follow the directions of the Earth. So it will follow, as the direction, the Earth rotates about its own axis. For the observer on Earth, the satellite appears to be at rest. Yes, the satellite will appear to be at rest for an observer who is watching the satellite from the ground can see that the satellite appears to be at rest itself. It's not moving at all because the Earth, it will follow the same direction of the Earth and it will have the same angular speed of the Earth itself. So for that reason, for an observer who is watching the satellite from the Earth will observe this, that the satellite will appear for him to be at rest. The time period of the satellite is 24 hours. So exactly, so it will revolve around the same angular speed. So the time period for that satellite will be exactly 24 hours. And the distance of the satellite from the Earth, it will be around 36,000 kilometers. So it will be around that distance. So our India's geostationary satellite is placed at a height of 35,950 kilometers. So this is our satellite which is placed at a particular orbit. Our Indian's geostationary satellite is placed at the height of 35,950 kilometers. But usually this geostationary satellites, they are placed at around 36,000 kilometers. So this is all you have to know about geostationary satellites. The next topic is polar satellite. These are low altitude satellites. So that means low altitude means that are placed at lower heights. So these are low altitude satellites located at height about 500 to 800 kilometers. So geostationary satellites were placed at around 36,000 kilometers. So here this polar satellite will be placed around 500 to 800 kilometers. So this is the reason why they are called as low altitude satellites. So these are the satellites revolving in polar orbit. So polar orbit means that travel in north-south direction. So these are the satellites revolving in polar orbit itself. For that reason itself they are called as polar satellites. So for this example, we have IRS satellite. So this is from India. So Indian remote sensing satellites. So we have this. So that is a polar satellite. Okay. So now the next topic is uses of polar satellites. So we have uses for this polar satellites. So the first one is remote sensing. So remote sensing. So modern day aircrafts and drones will have this technology, remote sensing. So they can remotely access any location. Okay, they can know information about any location by traveling around certain height. So for this, the remote sensing, this polar satellites can be used. Okay, so the next one is meteorology. So this, what does this meteorology means? So it helps us to study about climate change and atmosphere. So these polar satellites can be used to study the climate change and the atmospheric changes that are happening around the surface of the earth. So for this reason also polar satellites can be used. So the third one is for environmental study of the earth. So we have certain regions on the earth which are yet to be explored. Even our oceans are not explored properly. So there are about more than 70 to 80% of the ocean that are yet to be explored. Okay, so all those places, even our Himalayas also. So in Siberia, our Antarctica, we have many places like that that are yet to be explored. We just don't know what that is present there. Okay, for that reason, to study those places, for those regions, how the climate can vary, how the temperature can differ from one place to another place. For all these environmental studies, we make use of this polar satellites. So these polar satellites have huge advantages in these regions. So all these are uses of polar satellites.